The United Nations has defined the water-food-energy nexus as the principal challenge of the next generation. All engineering disciplines have a role in providing these necessities in a reliable, safe, and sustainable manner. The engineering chemistry program is focused on three elements: pharmaceutical/agrochemical synthesis, energy conversion and storage, and chemical diagnostics. This virtual reality experience illustrates each element of the program in the context of water, food, and energy, using Wolf Island as a small-scale ecosystem. You are currently aboard the Wolf Island ferry, approaching a dock where you can access 3 vignettes. You teleport around using large circular trackpads you can see on your controllers. Pressing down on them will show you the arc of your teleportation and the areas you can go to. Releasing the trackpad will teleport you to the end of your arc. Shifting to renewable energy sources such as solar and wind farms requires methods of storing energy in transportable forms. This includes batteries, electrolyzers, and supercapacitors, all of which are designed using the principles of electrochemistry. The EngChem curriculum will provide you with the foundational knowledge needed to design these types of devices, putting you at the forefront of alternative energy system design. In this activity, you will adjust the solar farm array to maximize its electrical energy harvest and use an electrolyzer to convert this electricity into hydrogen for future use. Grab the joystick in front of you with your controller by pressing the trigger and use it to rotate this array of solar panels. This method of storing renewable energy is a portable form that is suitable for use in stationary and vehicular fuel cell systems, allowing people to power devices when the sun does not shine or the wind does not blow. This is just one of the energy conversion systems you will study in engineering chemistry program. Biologically active molecules, including active pharmaceutical ingredients and agrochemicals, are essential to human health and are increasingly difficult to synthesize and isolate. The process synthesis element of the engineering chemistry program will teach you the full range of methods of preparing bioactive molecules, as well as the engineering tools that are needed to conduct these syntheses on a large scale. In this activity, you can examine the chemical structure of metolachlor, a herbicide that is used extensively for crop protection. The two molecules you see are identical in every way, except for the arrangement of the 4 substituents about the highlighted carbon atom. The existence of this chiral center in the molecule has dramatic effects on bioactivity, with one enantiomer providing crop protection while the other has no effect. Use your laser pointers to manipulate the molecules. Point at the molecule with your controller and press the trigger to grab it. You can rotate it by pressing the right or left side of the trackpads. Try to see if you can impose one molecule on the other. Environmental monitoring, medical diagnoses, forensics, and security systems require accurate and sensitive methods of detecting and quantifying trace amounts of target molecules. Engineering chemists study contemporary analytical chemistry, as well as the engineering science needed to design devices for field use. In this activity, you will tune a spectrometer to specifically detect metolachlor, an agrochemical herbicide, in a stream adjacent to a farmer's field. Press the red button on the side of the box with the trigger on your controller. Grab the dial on the spectrometer, rotate it to try to detect metolachlor in the water.